It seems like a day cannot go by without AI being integrated into something new and the topic of conversation. I enjoy talking about technology, and AI is one of those subjects that you just cannot ignore. Now, one thing that does interest me about AI is how AI can be biased. Now, the way that AI works is that it is fed information, and with that information, it produces an output or some sort of result. The way that I'm going to demonstrate how AI can be biased is with a mortgage loan app. So I'm ready to buy a house, but I need to take out a loan. So this app is going to ask me some information about myself, like my zip code, my credit score, my income, and my budget. And based off of that information, it's going to approve or deny me for the loan. Now, you would think that the determining factors are my credit score and my income, but in actuality, it's going to be my zip code that determines whether or not I get the loan or not. So if I enter a zip code that the app does not like, then it's going to reject my loan. What it's also going to do is it's going to still offer me the loan as a backup option, but the option is going to be to get the loan with a very steep interest rate. Now, somebody else could be applying for the same type of loan, entering the same criteria as me, or even worse, and because they entered the right zip code that the AI approves, they're going to get offered the loan and offered the loan with a lower interest rate than I was offered. So this is one way that I can demonstrate how AI can be biased is simply off of zip codes, because we know that certain demographics do live in certain neighborhoods, and if we're going to determine where somebody lives and whether they get a loan or not, it's going to show signs of biases. So I want to begin by talking about the architecture of this app. It is written in Python, and the UI is using Streamlit. The data is going to be organized with pandas, and I'm bringing in Scikit to use logistic regression and standard scalar. The logistic regression is going to allow us to compare the X values to the Y value. The X values are going to be zip code, credit score, income, and budget. And then the Y value is going to be our approval. So is this approved? That's going to be our Y. And what we have is we're going to have two sets of zip codes, our rejected zip codes and our accepted zip codes. And these zip codes are going to be inside of the app for you to select on. And depending on which zip code is selected, that is going to determine if this loan is going to be approved or not, irregardless of income and credit score. That also is going to be saved in the all zips variable to hold both sets of zip codes. Now, here is where we're going to have our model learn from this information and this data here in order for it to understand that zip code is going to be what we emphasize on in order to approve or deny the loan. Now, income, budget, credit score, and zip binary, they're all going to matter. But again, what's going to matter most is what zip code was actually selected. Now, in our human everyday thinking, if my income is high and my credit score is high, I would have more probability of being approved for the loan. But that's not what we want to happen. Again, zip code is going to be that determining factor. So the way that the model is going to learn is through a lot of different calculations that are going to be happening in the background and simultaneously. It's going to be using algebra, statistics, and calculus to do things with each of these numbers in every column and throughout each of these numbers in order to figure out, hey, would this number actually be approved? What is a probability that this information would be approved? So it's going to be comparing all of these things, which is X, to our Y approved here. Now, when we look at this straightforward, we can see zip binary and approved already have two matching sets, 4 zeros and 4 ones. When we have things set up like this, 0 and 1, that tells the computer a situation of on and off or true and false. So our 0 is going to represent no, and our 1s are going to be representing yes. Now, when we look at these other numbers here, these are way heavier than a 0 and a 1. They're far out of reach. The computer is still going to interpret them, but the model may not work in the way we intended with these numbers being so large, because it's going to think, well, if these numbers are so large, then the loan should be approved. But that's not what we want to happen. So behind the scenes, we're actually going to crush these numbers down into a similar pattern for zeros and ones in order for the accuracy of knowing our zip codes is what's going to have more emphasis on it. So these other selections, income, budget, and credit score, these numbers are going to be crushed down where they're just not going to have as much weight in comparison to this zip code area here, because this is an exact match in these instances. So where that all happens is we'll have our X. So we say our X is income, budget, credit score, zip, and then we have our Y, and that's going to be approved, which are what's compared against each other. So we're going to have our model here, and it's going to do all the math in this fit method here. And inside of there is where it's doing all these calculations, adding and subtracting in order to figure out how close it needs to go to approved and what it learns from that. Am I right on being approved? Am I wrong? And doing all these formulas in order to figure out, one, zip binary has the most emphasis. And once it figures that out, it's going to stop. The standard scalar, again, is what's going to crush these numbers down into smaller numbers, and I'll show what that looks like. And then this logistic regression, of course, is part of the comparison between the X and Y, and just being more concise on the information that we're looking at there. So one other piece that is important as well is right here with the zip input. So when we do select on a zip code out of all of them, we're going to select the zip code, and if it's in the accepted zip codes list, we're going to assign that zip code as a 1. If it's not in accepted zip codes, we're going to assign that zip code as 0 instead. So that goes back to here, where we already have these zeros and ones set up, because we don't want the zip codes to be a 5-digit number. We want them to be equivalent to the answer that we're trying to reach, which is approved. So that's where we're going to break that down from a zip code registering as true or false in that arena. Okay, so I am going to go ahead and apply for a loan, and I'm going with Runyon That Munyon Loans and Company to apply. And I am Johnny Bravo, and I make $100,000 annually. The loan amount that I want to borrow is $350,000. My credit score is a little bit more than 720. I'm going to make it 749, and the budget that I want to stay around is $3,500. Currently, I live in the 90210 zip code. My 90210 zip code is going to be seen as a rejected zip. Me being Johnny, I don't know that, but my app knows that. So when I go ahead and submit my application, whoa, I'm denied? So when I look at the information here in the background, it's telling me that I am denied for this loan. And it lets me know that, hey, I just don't meet the criteria, even though I have this credit score, I fall outside the prime zip tier. But hey, I still qualify for the It's a Scam builder loan, and I can get this at a 14.5% interest rate. Now, my $350,000 loan monthly is going to cost me $5,201.39, which is also outside of my budget. So now I got to make a decision like, hey, is this worth it? Or I got to probably even figure out like, wow, how do I not qualify for this loan? Now, if I were a different person and I'm coming here to apply for a loan, my name is Carmen Sandiego, and I make $45,000, and I'm gonna keep the $250,000 loan amount. My credit score is a little bit lower. You know, I got a little bit of, Klarna and some, Afterpays, something going on over there. And I'm gonna say I want my budget to be around $3,500, and the zip code that I currently live in right now is 12345. So I'm gonna go ahead and submit my application. Boom, approved. So with a $45,000 income, a $250,000 loan, my credit being 595, I get approved for this loan at 5.5% interest, and my monthly payment is only $1,840, and it's within my budget. But because my zip code is a zip code that this app prefers, I get the approval. So as a user, you're not really just going to automatically know what's determining outcomes. The developer is, the data science the data analysis, the data science, all the people that work behind the scenes to create this app are going to be aware of how this information gets produced. But if this type of app is being produced in a way that's unethical, that is a way that can produce outcomes for different people and have different experiences, where your zip code determines whether you get a loan or not your income or your credit score or other determining factors that should. So I wanted to touch on a little bit about the math that is going behind the scenes. I don't want to make this too complicated to kind of think about what's going on. But what is happening in the background is a combination of linear algebra, statistics, and calculus. And the data is starting off at a certain point on the graph. And you can think of this as a parabola where the data is trying to reach the center of that parabola way at the bottom. And the way that it does that is it adds weights or it lowers weights to the data in order to figure out where exactly is the bottom line, where 0 is going to equal pretty much the answer. So that's going to be on the y and x axis type of scale. And it does those calculations through and through. One thing that it also is using is, like we learned in high school, using a linear equation with doing slope. So when we're doing y equals mx plus b, I know at the time I didn't really know what y equals mx b was really for, except for the graphs, but now I understand how that is involved with training the data to reach a certain answer that we wanted to have, and based off of that answer we do an outcome. So what I wanted to show is just this table here that just demonstrates how the numbers are crunched down. So we want the model to know that we want to focus on the zip binary. And in order to do that, we need to make sure that the numbers all kind of have like a similar pattern here. 455,000, it's such a big outlier that naturally the AI is going to think that since these numbers are so big, yes, credit score, income, budget, we should be dependent on these numbers to make a decision, but that's not what we want. We want the zip code to be what is dependent, or to what is focused on. So we crunch these numbers down with another type of equation, min-max, to kind of transform these larger numbers in between 0 and 1. So we have a pattern here where all these numbers in these columns are in between 0 and 1. And it's going to do its calculations per column to see, okay, zip code holds the most weight, but then also it will add up these rows too, in order to still understand that, yeah, out of all these areas, still zip code has the most probability that if the zip code is this, it's going to be approved. If the zip code is not this, it's going to be denied.